Thank you. Thank you, everyone, for coming to my talk. As such, title is Event Streaming, and then for Multi-Agentic Generative AI Workflows. It's actually a whole bunch of stuff, as you can tell. I was here, I'm actually very thankful, first of all, that GOTO has invited me again to come and talk this year. And last year I was here too, I spoke about event streaming. Back then I was working for a company called DataStax and then on Pulsar, Apache Pulsar. So I think it's just natural that I kind of extend this topic and then more like exploring into how we can leverage on event streaming for generative AI type of workflows. But first of all, may I ask you how many of you are already, let's say, working with generative AI systems? Oh yeah, quite a few. Okay, great. And how many of you are, let's say, like working with agents system too? Like by any chance? Are you also like multi-agentic type of, yeah. Okay, that's fine too. Yeah, I mean, if you are. Yeah, and I understand it can mean different things to different people, but still, I think some of you, I assume that you are also here maybe, or how many of you are like completely new, let's say? I'm sure you're experienced developers out there, but how many of you are like new, right, to AI and generative AI and all of these? Yeah, feel free. Because I think I'm going to spend a little time to giving a bit of background information, because I've been to conferences in which I talk, and then afterwards people were saying that, well, I really don't know, all the backgrounds. So because agents is sort of like the next step. So we want to explain as to why we want to get into agents. So it's an exciting topic, so here I will start. And okay, so this is the agenda for today. I know it's actually about 40 minutes, so I'll try to be quick too, because as such, I'm going to cover a lot of things. But again, kind of brief intro and background of generative AI first, and then discussing the event-driven world and AI. And I think that's also largely an untapped area. And I'm kind of interested to find out how we can apply event streaming. I think very often we're hearing about event streaming, but how does it apply to the AI world? So in that sense, it's more exploratory too, or at least from my perspective, or you can share with me what you have. And then I want to explore too some of these concepts like RAG or vector database agents especially. Can we apply event-driven approach to it? And then some of the challenges too. I probably won't have time to do any demo, but then I have a Twitch stream and I'm doing live streaming, so I'll be sharing with that with you too. So, okay, so that's the thing. First of all, who is Mary? So here, just a picture worth 1,000 words. So currently I'm an AI practice lead for a consulting firm that's based in Ohio, in Cincinnati, but we're all remote. So AI practice is brand new for consulting. So I'm also building that up. And as you know, if you're into consulting, there's a lot of actually pre-sales work too that goes into it, in addition to the technology work. So, but I'm kind of doing that. But prior to that, I had about 6 years, and I'm still doing that, which is developer advocacy, and that's what I'm doing, the outreach, going to speak at conferences, outreach, and community kind of work, and I also run the Chicago Java Users Group, and also AI Camp. I think some of you are in the audience too from the AI Camp, from the Java Users Group, so thank you. And these are the different things I'm working with. I'm also Java champion. I help out AI Camp too, Chicago, as I mentioned. And then I now have ventured into generative AI, but before I was working more with distributed systems. That's actually how I kind of really more passionate in that area, but distributed systems is everywhere, as we know. So that's my background, and I'll share with you my contact information towards the end too. Okay, so just very quickly too, a brief background, right, of AI and generative AI, all of these things for those of you who may be new to this topic area. But first of all too, I'd like to kind of point out, right, the talk here today is more actually geared towards we're an AI producer. A lot of us are builders. We're trying to build. So I was just kind of looking at this as you can be the consumer too, meaning you can be using AI technology to enhance your work, writing a blog post, that type of stuff, for example, or kind of having, generate some poster images, those things. But I think we're here, most of us are developers, especially with this conference. So we're here to build AI applications and training models, for example, things like that. But it kind of just real quickly too, maybe it's not as interesting to some of you, but just to kind of mention, right, the 20th century, we have seen an explosion in the interest of AI and really has risen too. And basically, generative AI, I think the AI and machine learning were gaining in momentum, but not many of us actually are able to work with it. It wasn't very accessible for us, not until when ChatGPT came out 2 years ago, as we all know, kind of taken the world by surprise, right? All of these things, and we can actually use it now. Going to a website, chatgpt.com, you can ask questions and it answers you. So it's kind of exciting, but as you can see, that whole history behind it has pushed forth to here, where we are today. But ultimately, too, it's all about automation. We want things, machines, to do the work for us, to even think. That's the boundary we are trying to reach. But notice that right now we're still in AI and not AGI. As some of you are familiar, the artificial general intelligence, which actually gets into the reasoning part. And that's where I think there's a lot of controversies can go into. Can we actually make machines think, right? So that's actually a brand new area, which we won't get into today, but just thought I'd mention. But ultimately, too, we wanted to do the work for us. And so I think we should all be thinking of AI being a tool that can enhance our lives, not letting it take control of us. So just real quickly, too, so AI, machine learning, and deep learning, this is kind of a very kind of common way of explaining it in a diagram, but in the most simplistic way. Because we're talking about AI, it mimics the intelligence or behavior pattern of humans or any other kind of living entity. And basically, too, then we go inside this onion, so to speak. So that's machine learning. So that's techniques, the technique to try to train the computer to do the work. And that machine learning layer is basically, we want the machine to learn on its own and giving it data. So you train the machine to think on its own based on the data you give it. And as we all know, if you are already, let's say, working with machine learning before the ChatGPT explosion, we know too, is basically there's the supervised training, unsupervised training, and reinforcement learning on that level. And then the thing is, though, to make it really able to go deeper is the deep learning level, which is like neural networking. So just kind of quickly point out, the neural networking is basically that get inspired from how our brain is working. So we kind of follow that pattern of thinking in the neural level. So that's that. And let's look at the fascinating look at the generative AI kind of era. So it just came out in November of 2022. As we all know, it has taken the world by surprise. And why is it disruptive? And first of all, it's because now finally, I think we are able, well, I should say it's not the first time that we are able to use this technology, natural language processing, in which it can, basically the bot can now start to understand our instructions by just human spoken languages in kind of a grand level, right? And well, the thing is too, I have to mention is there is also Siri that came out too in the early 2010s, right? And that's when Apple came out with Siri. But the thing is, though, to make it massively available would be like this generative AI time. So you can think of, as developers, too, we no longer have to worry so much in some ways of, like when we're running a program, right? We used to be, traditionally, we have to say, you need to give the commands, and the commands have to be constructed in a very clear way, like what type of data, all these kind of things, right? That actually consumes a lot of our time to figure that out. But now look at it like GenAI is that you can just ask the AI, you don't have to worry about what type it is. The bot will figure it out. So think of it like that, it enhances our lives too. We can be moving on to more creative kind of work, right? And let the bot do all of these kind of, so to speak, like a crunching type of work. So anyway, so that's generative AI. As we all know, we are seeing it explosive. We can now see generative AI being able to answer questions like another human being, like you talk to it, and writing a blog post, and composing a song, and as we can see, generating a video clip, that type of stuff. So without saying, we already know. And this is just kind of pointing out, right, it's just kind of exploded since 2003, all the research being done. I mentioned about Apple brings AI and NLP assistant to the masses by first, releasing iPhone with Siri. So that would be the first NLP kind of product too. And then wanting to point out there's also Word2Vec too. I just want to point out some important paper. So Word2Vec is important because it's basically converting words, languages, words into vector. So that's what forms the basis of vector database. And so I just want to point out that in 2013. And then 2017 is the transformer paper from Google. And if you have heard of this phrase, right, that says attention is all you need. And that's where it kind of comes from that paper. So that kind of kicks off this new millennium of AI research. All right, I'm going to be a little fast, but anyway, so all of these are generative AI type of models, as we all know, and that's kind of part of the machine learning is training all these models. Takes a lot of time, takes a lot of money too, as we all know. But these are like the popular models out there, right? GPT 3.5, as we all know, is the first and foremost, and then 4.0, and now the 4.0, the O-mini, all of these things, Llama 2, Llama 3. So I won't get into all the details, as you are aware, but just want to kind of sort them out. We need these generative models to do all the work for us, and that's what all the power is. And then there are also generative apps, too, that actually makes use of this model. And for example, ChatGPT, Gemini from Google, and it's actually before Gemini was Bard. And all these kind of just very little sample of it, example of these apps. But the thing is to also point out is that one thing too about generative AI is basically too the initial, when we look at ChatGPT, is just dealing with text to text, right? But the thing is too, making it even more useful, be able to handle the different modes, right? And as we can see now, there's Gemini that comes out as a multimodal, for example, one of the powerful multimodal type of language model that can convert, takes care of text and images, code, and do all of these conversion in between. So basically, multimodality is a very important aspect of generative AI, not just it's able to handle text, or strings or spoken languages, but also handles, images and code and audio, all of these different modes. Okay, so then just wanted to point out too, as much as LLMs seem to be powerful, we can go in ChatGPT and ask questions, but notice that here's the hype too. It can do everything perfectly if it is a one-shot kind of deal. You want to ask a question, it will answer you right away. But by itself, the LLM doesn't have any memory. It cannot add any attributes to the answers. And it's basically serverless, right? Stateless type of functionality, unless you write some program. For example, using LangChain library like that to kind of chain together your ChatGPT type of application. So it's very much, you have this zero-shot type of question, and it comes back with the answer. But the thing is, too, in order to make this generative AI technology to be more useful is to be able to use it for more serious type of applications, such as some of you are working for example, enterprise type of IT shops, right? You are dealing with flight reservation systems, you're dealing with a mortgage application. So it has to go through many stages. So I got asked a lot of questions too that people are asking, what can I use GenAI for? And that's what I think we're all trying to figure it out. What can it be used for? But right now it's really very good at specific tasks, do one-shot kind of deal. But now the trend is that we want to move towards the next step, which is to make it more able to handle scalability, able to deal with complex workflows, that type of stuff. And that's what the challenge is lying right now. A lot more industry, all these research is going on, right? We're kind of figuring out all of the companies coming out of innovation, products like that. So, okay, just want to point that out. But as such too, generative AI still, coming out, is able to do a lot of great things for us because it's more accessible. As I mentioned too, now you can just use some interface, or even using Ollama, for example, you can run your language model locally, or using like LM Studio, which is a UI one that you can download models and ask questions and kind of interactively. So a lot more like, accessible for all of us to use. So this is kind of still, look at it like is, kind of a nice kind of progression of human history getting to this point. But we have a lot more work to do, right? So, okay, so here I'm just gonna maybe skip more of these, just talking about GPT. I just assume you all know is the transformer, ChatGPT, all of these things. And NLP is an important, invention or research type of a field, right, of computer science and linguistic too, that enable the NLP to work, right? Enable the bots being able to understand languages. LLMs is what we work with as developers. We interact with large language models. But as such, right, it is very expensive, wanting to point out. It's also not very sustainable because there was actually also research is showing, as some of you may know, if you want to ask your bot some questions like ChatGPT, it actually costs more money if you have to check how much energy it uses, right? It's not a green energy type of thing. It's actually, if you use regular Google search to do your searches, is actually much cheaper too. So that you have to kind of keep in mind. But there are lots more research being done now. For example, NVIDIA, right? They are producing massive like GPUs technology. They are able to bring down the cost, being able to cut down all of these costs to kind of do all these processing. Okay, so that's that. And just kind of getting to this point is how does it fit in? Is basically, if you go back to that onion diagram I have, there's AI and then machine learning, deep learning. So inside the deep learning, as you can see there, the transformers, the GAN and the VA, those are like more computer vision type of technology for image generation. LLMs, transformers fits into that deep learning space. And then it also leveraging on NLP, as well as data science too, that as we all know, data science is kind of closely interweaved with AI work because all of the artificial intelligence, machine learning is depending on this huge amount of data. Okay, so I think we're getting to this point, sorry. It's a lot of information. I understand I probably shouldn't be spending as much time, but now we get into the event-driven world and AI. So I gave you a bit of kind of introduction about AI, but let's kind of talk a bit then about event streaming. How many of you are just curious to our working, say, with event streaming system, maybe like Kafka and all of these? Yeah, okay, great. So I think the event streaming, as we all know, the fundamental thing about it is that it enables you to do kind of real-time processing. That's kind of one aspect of it. And also can do asynchronous type of work and also break down, for example, like data can come dynamically really fast like that, right? So for me, I've been like wondering, why is there not more papers or talks or research being done to examine like event-driven world and apply those techniques to AI. And I realized it's actually not easy. As we all know, yesterday I was hosting that talk I think by this, he talked about distributed data. I forgot, Jeffrey, right? And anyway, and the Hall South. And basically, he's a distributed data flow expert, but he also was explaining it's actually very difficult, as we all know, doing distributed systems and multiple streams. So to me, I feel that maybe that's one area of the future of AI is to apply the techniques of event streaming because you can be handling data stream from many sources, for example, and dynamically provide you all of the data that's needed, right? So then let's kind of take a look too at events. Fundamentally, if you look into it, what event is essentially an occurrence. And so if you have to look a bit more scientifically, it's basically based on theory of relativity. Relativity is basically the fundamental entity of observed physical reality that's basically handling three coordinates of place, of time, and of the space-time. So I know you may be saying that, well, we're not into theory. But the point I'm trying to make is that, as we all know, events can happen, and it happens, and you need to be able to capture it. But the good thing about doing event-driven style of programming is, again, you can immediately grab information and apply it to what you need right away, instead of the batch processing that traditional computing are more used to. Like, say if you work in a bank, a lot of times, all of these changes you collect during the day, you process it at night because it's cheaper to do it or more economical to do it. But why can't we do some things dynamically is what I'm looking at. Anyway, so let's see, kind of, again, back to the AI topic, right? At the heart of artificial intelligence is data, and then also the flow of data in many directions too. So I think it's not very easy to do, but again, I believe that's one of the area we can get into more in the future. So working with data too, if you kind of look into working with data, essentially there's the architectural level. You can have event-driven type of architecture, and it just means that your architecture of your whole system might be taking on more of that support of events. For example, you can have maybe using libraries such as Kafka or Pulsar, something like that, or ActiveMQ, like queuing system, to basically capture data as they come. That type of, if you leverage on that, you qualify, I guess, your system as event-driven. And basically, too, notice that for data, too, it exists in different states, too. It can be at rest. It's like in a database, for example, in permanent storage, or in motion, right? As the data is being like flowing through some systems, or it being just simply in use. Maybe like you extract like a SQL database, you select some data, and then you apply some updates to it, that type of stuff. So, and as such too, there are many techniques that handle, right, all the event streaming type of scenario. There's, again, well, event streaming, right? Streaming is when data flows through stream and it just come in and it's not, usually it's just bytes. If you think of like data traveling in the wire, it's just bytes traveling through the wire. And you can have multiple things. For example, I worked at Chicago Mercantile Exchange. I work on systems such as they're like they're published, right? They're, what is it called? All of a sudden, I can't remember. But anyway, there's like a trading market. You need to like pump in all of these data, all of the price, right? The price maker, that's right. So and so you need to like get them maybe through WebSockets. You are receiving data like that. Those are kind of event streaming, kind of a way. And then there's also event messaging that you basically can be using PubSub type of capability to handle publish, subscribe type of techniques to do it, or using queues, right? And then queues is more like you publish data gets published to a queue and it gets picked up, first in, first out type of thing. So I just wanted to mention a couple of techniques. And then of course there are also event sourcing, and if some of you are working with those, there's CQRS too. It's essentially not making use of your, essentially keeping track of the events that happens, capturing the data at different points in time, and you'll be able to replay, for example, things like that. So as you can see, data is kind of another kind of aspect of complexity we need to deal with. Now, then gets into generative AI streaming usages. So I like to kind of examine, right? There are just different kind of, opportunities we can be using event-driven type of approach. Let's say, in your generative AI the application, let's say, you're doing inputs. It can be like, the prompts. From the prompts, you can get all of the input from command line or from like browser or from mobile apps type of scenario. And in fact, just wanted to describe to you, I'll be doing a talk at KubeCon too, if maybe some of you go to the Kubernetes conference, a big one. I actually will be talking about using Rising Wave, this stream processor, and essentially it's analytics. But the thing is, we're coming up with an example of, for example, it's not exactly, well, it's kind of, we wanted to create some use cases. So we want to simulate, let's say, right, we want to capture like a Twitter feed. And essentially, too, from there, we're using a Kafka topic to kind of capture like, the tweets that comes in for certain data that may be a tag with some, for example, like GOTO. We want to capture that tag. So from there, we'll simulate a feed that capture the information right away. And then from there, we'll take the data and then create prompts, right? The prompts can then be fed into maybe like a ChatGPT type of app, and then query, essentially ask ChatGPT some question based on that tag, that type of stuff. So that's kind of an example of how you can be creatively kind of using like generative or using kind of event-driven type of techniques to kind of help with your application too. Okay, so then there are also generative AI like intermediary steps, right? Let's say doing retrieval-augmented generation type of operation, as some of you may be familiar with, right? And I'll go into a little bit into RAG a little bit too, for those of you who may need it. But essentially too, you want to, again, LLMs is not very capable. It doesn't have any data that's kind of, you train a model. You need to train it with a fixed set of data, and the data is outdated by the time it gets trained, this model. So then you're using retrieval-augmented generation, these techniques to be able to feed in real-time, up-to-date data, for example. So in that case, too, the sources from these RAG operations can be actually taken from a live database or taken from a file system or WebSocket or message queue or Kafka topic too. So those are kind of cases in which you can leverage on real-time data that way. And then also too, from there too, as I mentioned to you, that example that I will be doing, that one will be, we want to immediately take these top tags and then form prompts and then be able to send it to the LLM for processing, for searches, that type of stuff too. And then of course too, for generative AI, the apps too comes back, right, with some responses that are from your LLMs. You can also immediately be capturing certain things and, manipulate it and then send it back to the query, the person who is querying, to like ask questions essentially. So these are kind of just examining GenAI streaming type of usages that you can think of using. Okay, so then just wanted to kind of point out, right, benefits of this event-driven approach. Essentially, too, it helps, with handling the dynamic nature of data and its flow patterns. Data doesn't stop there. We have to kind of remember that too. But it's very hard to do. Usually, you try to capture what is happening, that type of stuff. And then, of course, help with asynchronous type of processing too, because data happening, and then you can immediately get it and process and do something to it too. And the real-time kind of aspect too. But also to be aware, if you're using event-driven type of approach to doing any systems, is usually more difficult to debug because the data comes in immediately on the fly, that type of stuff. So you need to kind of have ways, especially if you're doing IT, true system, you have to have ways to capturing it. So another way, as I mentioned about CQRS, right, the command query responsibility segregation pattern. That one, you can use those kind of techniques, event sourcing, essentially saving all your events, data changes at every point in time, then you can use it for debugging, backtracking type of purposes. But as you can see, still, to track the flow of calls, and especially you can have many clients doing queries at the same time for some program. So you have to have ways of identifying all of these data that comes in and be able to track the flow of calls, who is it from, at what time, all those things. So you have a bit of more work to do on sort of the back end, doing like observability type of work. So yeah, so that's what it is. So, okay. Let me kind of be a little quick now. So there's a RAG. I already kind of mentioned a little bit about RAG too. So I feel that this would be an area you can apply event streaming type of techniques. And RAG, as I mentioned, is basically Retrieval-Augmented Generation. It's to supplement what the LLM doesn't have, this up-to-date data, first of all, or, whatever reason. Let's say you are also in an IT company and, financial institutions. There are data that you don't want to get exposed to the outside world or private data, right? Certain insurance company or legal documents. So you want to be able to feed in these, private data that's not exposed to the outside, that type of stuff. So you can think of using a RAG model to do that. And again, there are two models to this RAG pattern. One is the retrieval model. The other is generative model. I just want to explain too is that the role of the retrieval model is basically, in a nutshell, retrieval is kind of like acting like a librarian. You are pulling in relevant information from, let's say, database or some sources or a corpus of documents. That's the retrieval side. And then basically from what you have gathered, of course you do some parsing or doing some filtering, whatever you need, right? Chunking, all of these things. And when it comes in, then you need to feed it over to the generative model, that side too. And so the generative model will act as a writer. So eventually too, you'll be submitting your prompts, for example, to the LLM and ask questions. So what comes back, you also want to pass back to the generative model to enrich it and making it more contextually rich. So that's essentially what this RAG pattern is. And notice that it's only architectural pattern. It's not how you implement. And how you implement it is actually quite free, as you can see. And you can implement any way you want, but you essentially make sure there's the retrieval side and the generation side. Okay, so that's that, and yeah, so I think I know I explained everything really quickly too. Okay, so really quickly to also explain a little bit about in the generative AI type of systems when we build it, I talk about RAG. So you may be wondering, well, then what to do, right? All the data that flows through, you want to have some way of storing it. You can, of course, use in-memory type of facility to help you to kind of manage all of the data that gets generated, for example. But also, too, then you can also consider using a vector database. So one thing, really quickly explain what is vector database is basically a purpose-built database that serves up vector data type. And what are vector data types? So if you look into it, right, it's essentially, well, what is explained is it relies on vector embeddings. So as I mentioned earlier, right, there was a word2vec paper that was written up, in the 2013 or 2003. And so essentially, too, we want to be able to look at all these languages and be able to store them properly inside a database. And as we all know, generative AI type of data is kind of multidimensional. So just kind of understand it, meaning that as you can see, right, AI, we're dealing with not just scalar type of data that we are more used to. The scalar data is more single dimension, maybe like 1, 2, 3, all these things. But the thing is, we want to express using numbers to express these complex concept, right, in a generative AI situation that can handle the dimensions, the different, maybe weight, all of these things, then we need another way to represent the data in this complex multidimensional format. So essentially, too, we are using vector embeddings, and they are essentially numerical representations of your data. So let's say, you have a very simple example. It's like having a string that comes in, it's like, I have a dog or something. It gets translated into like multidimensional, and it's essentially, if you kind of look into a vector database, gets translated into floating point numbers, but they are an array of floating point numbers. So as you can see, it gets complicated. And why do we do that? Because you can use the technique of matrix calculations to do it. So if some of you may be also mathematicians or have studied mathematics, and that's using linear algebra to do it too. So maybe you have done matrix calculations, like using, think of it like two-dimensional, like kind of a representation of some data. And it's all like, in a grid format. So we're applying the matrix map, the linear algebra, to do all the calculations. So I know it's a bit kind of theoretical, but essentially, too, just trust it that there are different kind of techniques, and one of which is actually the most common technique is being used is called approximate nearest neighbor. So over here, just a very simple explanation too. I just thought I mentioned because I worked with it for a while. So just think of some data that comes in, you're expressing it in terms, visually is, a vector. So very simple, there's only 2 dimensions. Then you basically have the data being expressed, and that's how they are located on this 2-dimensional map. So, okay, here we go. So just a very simple, another simple kind of hello world example. In reality, it's more complicated than that, but basically it could end up a cat and a dog is ended up in those space, in a 2-dimensional space, and a house is over there. And of course, how it gets translated to there, as you know, machine learning too, you look at all the data, you have to categorize it. Like say cat and dog are animals, so they are closer by nature by this thing. But of course, also wanted to kind of talk about is that in the vector, there's also, when you translate them into numerical representation, there are also specification that tells it what number should it be translated to. So let's say there are specifications too that are right now, for example, OpenAI, it has the different specifications. So if you trying to work with vector data, you need to make sure you use the same spec for storing your data and then also for querying too. So I just thought I kind of should share with you this kind of information too. And then this gets a bit more complicated is when we deal with real like data is that, as you can see, the 2-dimensional is simple, right, vector data. But in reality, we live in a complex world. So basically, it makes use of different layers too in this complex mathematical formula. Then you can kind of deal with very complex data that we're seeing right now. Because we live in a complex world, we talk in complex ways. So that's how it is. So again, don't worry so much about it. I thought I'd share with you so you have some idea, the complexity that goes behind it. Okay, so these are just vector database I thought I'd share with if you ever needs it to work with RAGs, for example. PG Vector is an extension of Postgres, and Milvus is another open source, and Chroma Fast is from Meta, and Quadrant, and Weaviate. This seems to be kind of a more popular type of or kind of proven kind of vector database you can work with. There are many others too. So, okay, and then I won't get into all the details because I'm talking too much right now. I need to get into the agent stuff. Okay, all right, then agents. Okay, so after talking with all of these, of course, we live in a complex world, and getting it more complex, but kind of exciting is the fact that, we live in a complex world. We want these systems to be able to become autonomous and do more work for us. So this is the new concept that came out to kind of more like earlier this year, essentially is agents. First of all, too, agents are not by itself, right? The concepts of agents is not new. As we all know, many systems already are leveraging on agents. Essentially, too, if you think of agent, not even like associating with computing, world. We have insurance agent, right? And a lot of times you need to buy your insurance. You don't do it directly through the insurance company. You go through an agent. So that's kind of like the same kind of concept. So in the generative AI specific context, is a very new concept that came out, I think it was earlier this year when the papers came out too. For me, I've been like following deeplearning.ai. If you ever want to go to that site, it's got good information. And then it's Dr. Andrew Ng. I really like his talk too, if you ever look. He talks about the agents, and that was earlier this year. So I was following, it's really cool because he also believes that AI, the agents will become more sophisticated. And why? Because if you think of it, right, the complex world, you think of having agents doing some of the work for us, and then each particular agent is only responsible for some specific task. And what will actually need to happen is that we need to implement these agents very carefully so then among themselves, they can talk among themselves to do all the work too. So can you imagine it's actually very complex too. Like think of, we are working in IT, let's say a consulting firm. We have software engineers that are specific to doing development engineering work, and we have QA folks doing testing, deployment folks doing all the deployment. All of these are complex, right? Things don't always go right, and you have to talk to one another to solve problems. So essentially, too, if you think of agents, it probably would be a good kind of way to kind of solve these kind of complex workflow problems, is what it is. So essentially, too, generative AI agents within this software context, they're supposed to orchestrate, complex workflows, coordinate the activities of different agents and process logic, evaluate answers. That's the agent. And so now let's kind of look a bit too into some of these agentic design patterns too. This again, I learned it from Dr. Ng. I thought it was very cool. It's essentially there are 4 design patterns. It's reflection, tool use, and planning, and multi-agent collaboration. So this one too, again, I'm looking at this, right? It's like this, right? Reflection, first of all, what it is that it's just like anything, right? Okay, let's look at right now, LLM, you do 0-shot kind of asking it for help, and it will just come back with you with some single answer. But the thing is too, is that we don't want to trust the answer from LLM right away. And then we want to feed back this, the initial response back to the LLM and ask it again multiple times until you get the perfect answer. So that's the idea of reflection. But instead of us doing it, why don't we have an agent to help us with? And that's what it is. It's autonomous in that sense. You design your agent, the agent will handle all of these things for you, get back the response. You code it so it kind of knows we submit that question to the LLM and ask for more clarification, for example. And right here is kind of pretty cool. I saw this, and it's like, for example, your coder agent is LLM, and you write up some code, and then there's also a critic agent too that goes in and check, right? It's something is wrong, please fix it, and it writes another one back and forth until you get a perfect answer. That's the idea of a reflection. And then there's also tool use. So tool use is essentially too, like you basically also are not trusting the LLM knows the answer, and that happens. And know that LLMs are not all magic because it's fuzzy logic, right? Nothing is determinate. Kind of like you can't expect LLM to be, exactly the same every time. Anyway, so essentially tool use is that you ask LLM the question, but you also want to set it up so then you give LLM some help. essentially suggesting that, well, if you can't find the answers, please look up on the web, look up some answers for you. So that's kind of giving out, for example, over here from Bing Copilot, you can be asking some question, what's the best coffee making according to reviewers, and basically too, the Copilot can't find it, then it will actually look for what you give it as hint. Maybe it goes to the web and search for answers for you, kind of like that. And likewise too, code execution tool, you can also give it like more help essentially to the LLM. So that's the idea. Okay, let me make sure. And then here too, it's interesting. There are a couple of libraries that seem to be more mature to handle multi-agentic. So this one is actually from Crew AI, and it explains essentially these agents, right? The agents itself too, it's not just blindly do the work. It needs to have more initiative, so to speak, right? To be able to reach out to other agents and ask for help if they don't have the answer. So that's the idea, like that. So I just thought I'd kind of share with you too. So I will share the slides with you afterwards too. Okay, and then there are also another agentic pattern is the planning side. And this is kind of an example too. It's like we want actually the LLM to be able to do all the planning. So then you don't ask the agent or don't ask question in a very step-by-step way. You can say, well, I want you to be able to in this example, it's like generate me from this image. I want to actually have a girl doing that. So then it will actually go in there and then do various kind of calculations and figure it out. Identify the shape, for example, things like that, and eventually to search for a girl image and replace it with the boy like that too. But anyway, the point here is that you want the agent to be able to help figure out all the steps that are needed to do the job too. So then you don't need to worry about if you need to do something, don't even give it hint. Have it figure out all the steps. That's the idea. But again, this is quite new from what I'm reading. I think there's still a lot of research to do because I think the accuracy isn't too high yet, or at least the last paper I read about it. So it's just interesting stuff. Okay, and then also too, it gets into the fourth design pattern, which is multi-agentic collaboration. So as you can see too, I kind of mentioned about an IT consulting firm, for example, and you have all these kind of different agents that are responsible for very specific tasks. You want to be able to have actually the agents be coded up so then the agents can become, again, take initiative to ask questions and figure things out and autonomous, essentially. So again, this is kind of an interesting diagram. And also there's a paper written too. If you go to that, there's I can't remember the name of that. It's well, anyway, I'll share with you afterwards too if you're interested. But this chat dev architecture is basically communicative agents for software development. And the people were doing the research on this, and they're using this as kind of an example of driving how you can do multi-agentic collaboration in a complex kind of scenario. So if you're interested, I can share that paper with you afterwards. And I realize I only have 1 minute left. Okay, so I won't kind of take as much time, but just want to share with you too. So if you're interested in trying some of these things out, for example, Crew AI takes on a more role play type of model too. So when you go in and do coding, you need to actually think ahead of time what you're trying to solve the problem. Think of all the different roles, and then you can then assign them and then do all the configuration that's needed. That's the idea. So Crew AI seems to be quite good, and also a little bit, to me, I think I look at it too, it seems to be kind of a bit more intuitive in my opinion. And there's also LangGraph, for example, is from the LangChain family. So if you kind of are already using LangChain for ChatGPT, I think LangGraph seems to be the kind of something you can consider doing, and plus it also supports like graph theory too. So if you're into like using like DAG, right, the graph, then you may find it can help you to do multi-agentic type of implementations. But if you're not as familiar with graph, it might take a bit of time. And then there's also AutoGen from Microsoft too, is an open source library too that seems to be quite popular as well. And then there are other ones too, but these three seems to be the major agentic libraries. Okay, so and just very quickly, and as you can see, all the challenges, just wanted to remind, right, the GenAI is not, solve all our problems. There are hallucinations if it doesn't know, how to answer it properly and all these, just be aware of that. there are ethical concerns and real-time, up-to-date data, all these problems, and how do you solve scalability, security type of issues, and also very energy intensive still at this point. So we have to be aware of that. So. Okay, so with that, I hope it's been helpful, or at least giving you some idea if you want to go ahead and think more into this area. I believe too, like using the agentic approach probably is a very good way to move towards moving generative AI to another level, able to solve more complex problems and workflows. So, and with that, I want to thank you, and this slide deck can be accessed from me if you're interested, and I'm always available too. So there's also some open source information about those tools I told you. Also, I have a stream, that's right, if you're interested. I'm trying to, I started a podcast now with AI too, just so you know, but I'm doing it on this same stream. So if you want to follow me on there, and I'm doing the podcast with a Java champion. He's started working with machine learning, and he's based in London, Manny, that's his name. So we started doing it. We're going to do another episode. We want to do it so then it's not just like business focused. I mean, it's important, but we want to make it more like really, it makes sense, right, for developers building very beneficial systems too. We want to bring it to folks, yeah. So yeah, so that's me if you want to follow me there, Twitch and YouTube. And then with that, I want to thank you very much, and please keep in touch and give me some feedback too. Thank you so much. Yeah.